Alright, we're back. We got a full week this week, 5 days. Same assignments though. We're going to have one survey that will be due on Wednesday just to kind of be able to touch base with you guys with that. And then we got systems of linear inequalities. We're in systems still. We'll kind of see if this is our last week. It could potentially be our last week of systems. I may expand on it a little bit more next week. We'll kind of see though. I'll kind of make that decision probably midweek this week or so. But this week we are graphing linear inequalities. So I figured Delta Math is going to be the best bet for this. Graphing is actually pretty easy on Delta Math. I'll kind of walk you through it a little bit. But you're going to have a total of 13 questions on this. 10 of them are having to do with graphing. The first 5 is just one linear inequality at a time, so one line at a time. The second section is just plugging in some points, see what works for both inequalities. I'll kind of give you an overview of that here in a few minutes. And then the big thing here is the system of inequalities. We're going to solve those graphically, and I'll kind of walk you through that on Delta Math as well. The graphing you have 2 attempts on, just like we typically have been. You only get one attempt on the multiple choice question. So this middle section where there's only 3 questions is a multiple choice section. So you only get one attempt on those with multiple choice, since it's kind of process of elimination there. But yeah, so let's move forward with this. Some reminders: we're only looking at linear functions, so we're bringing back some y equals mx plus b. Reminder there: m is slope, rise over run. Hopefully this is all coming back. B is the y-intercept. 0b is the point that you would plot first, then use your slope from there to kind of get your next couple of points. Now, inequalities, we're not just graphing a line. We have to have a solid or a dotted line. If it's just less than or greater than, it's a dotted line. If it's the or equal to's, we're dealing with a solid line. All right, and I'll show you how to change that on Delta Math as well. Again, pretty easy, just maybe need to see it done once or twice to get us going. So we go through steps. We're going to graph the line first. All right, if you need to get y by itself, you need to get y by itself, but you graph the line first. We're going to pick a test point, and this is something we can typically do in our head, especially with Delta Math. We may just be forced to. You may jot yourself some notes down or something, but we pick a test point. If the test point is a true statement, then you shade the same side of the line of where the point is, and I'll explain that on the next slide and within some Delta Math as well. If the statement is false, then you shade the opposite side of the line from where the point is. Now with systems, you just do that process twice. That's about it. Now, graphing, recap. I'm just going to do it here. We got y is less than 2/3 x minus 4. We started our y-intercept. Y-intercept is -4, so that is 0, -4, or down 4. Now typically on paper we would use our slope, go up 2, right 3, plot 2 more points usually. On Delta Math you just need to plot 1 more point using the slope still. Alright, this is going to be a dotted line. So we got that. Now, my test point is going to be 0, 0. This is where this comes into play. My test point is 0, 0. It lies here in the graph. Obviously, at the origin there. Now, you plug it in for both x and y. 0, 0, both spots. We can typically do this in our head, like I said. 0 is less than -4. That is not true. So if it's not true at this point here, that means it's not true anywhere above this line. So what you end up doing is you end up shading below this line. Alright, so you shade below the line. This area right here is your solution. Any point within this region satisfies the inequality. That's what that's saying. Alright, that's generally what we're doing here. Looking at Delta Math, this is what it would look like on your end, system of linear inequalities. First section is what I just did, graphing linear inequalities. Now you may need to get y by itself. Bouncing back to the slides, I do have a slide here just showing very quickly 2 quick examples on how to get y by itself in a couple different scenarios. Big thing here to kind of pay attention to is the left side. I divided by a -1. You flip the symbol, so make sure that happens. Now on this one that we're looking at here, once we get y by itself, what we're graphing, sorry I'm bouncing back and forth, what we're going to end up graphing, whether you do this in your head or you need to jot down the work or whatever it is, it'd be -2/3 x, divide everything by 3, so that'd become -6 on that right side there, or on the far right. So this is the function that we would end up graphing. So that means I start down 6. Now to graph on Delta Math, you plot typically your y-intercept, -6. My slope, I said, was -2/3, so I go down 2, right 3. As you can see there, the line is already popping up. I just need to plot one more point, that's it. Now, it's a dotted line because it's not or equal to, so I change the line. Now it's a dotted line. I pick 0, 0 as my test point. Plug in 0 for both x and y. This one's nice in this setup. It just says 0 is less than -18. Is 0 less than -18? No. So you change the shading wherever it is. 0, 0 was right here. Alright, we said that statement was not true. 0 is not less than -18. So I change the shading, and I should be shading below the line. I go ahead, submit my answer. We're good to go. They show you all the work. Alright, now on these, remember, look at the examples if you need to. Alright, the examples are helping there. They're pretty good. Use what you need to. On this one is the only one that you're going to really need to get y by itself on those. This middle section with multiple choice, I just have it here. Get rid of this slide. This is just a screenshot of one of the problems that you could have. Which point would be a solution of the system linear inequality is shown below. You have a system here. Which point would satisfy both inequalities? All you're doing is plugging in the points until you find a point that satisfies both inequalities. It happens to be -8, 8. Here's the work for it. You can just type this into a calculator, you can do it in your head, whatever you want. Alright, you just have 3 multiple choice questions, just kind of testing those points out. Now, here's our last portion here. Now the actual systems. So two lines at once. Steps 1 through 3 are the exact same as what we did with just a single inequality. Now we're going to repeat steps 1 through 3 for the second line. Step 5, there is a step 5. Normally we'd be done. We'd find the overlap region, that's it. Step 5, you have to pick any point that lies within the overlap region in Delta Math. So I'll kind of walk you through that. So let's look at a couple examples of these, and then I'll end the video there pretty much. So these ones, the systems, are nice. They're already going to be in slope-intercept form, so we're okay here. As I'm going through this, as I'm looking at the problem, I double check what I'm looking at here. I'm looking at 2 greater than symbols, that's it. So they're both going to be dotted lines. You just graph one line at a time, so I'm going to go with that top line. So 4, slope is -x, so it's -1, so it's down 1, right 1. Plot yourself there. Deal with the shading of each line individually. I already said it's a dotted line. Now 0, 0 is my test point. 0 for y, 0 for x. All that is just knocks out the y and the x essentially. So it'd be 0 is greater than 4. Is 0 greater than 4? No. So your shading needs to happen above the line here. Now you can see the points already kind of ready for you. I move on to the second line. I start up 1. It's a positive 1/2 slope, so I go up 1, right 2. That's it. I already said it is a dotted line. and my shading. 0, 0 is your test point. 0 is greater than 0 plus 1. So is 0 greater than 1? No. 0 is not greater than 1 down here, so we need to shade above that line. This is your overlapped region, this top portion here. Alright, the top portion here is your overlapped region. You're not quite done. All you have to do is tell me some random point that lies within that region. It can be 0, 8. So 0, 8 works. You can go 2, 4. That'll work. I'll just prove it to you there. 2, 4. And that's what we got. I just picked that point. They picked a different sample solution point is all they refer to it as. It just needs to be some random point within the overlapped region. Okay. Notice here it said many other possible points that we have. All right. Let's walk through one more, and then we'll go from there. I'll turn you loose. So we got y is less than 2x minus 8. So I start down 8. 2x is up to right 1. Now, if you messed up, you can double click. So negative 8 there. If you see this, little symbol popping up over the line, that gets rid of it. So I go negative 8 up to right 1. There's my point. I already set it to dotted line on that one. 0, 0 is my test point. Is 0 less than negative 8? The answer is no. So we have that. Go to our next line. We go negative 2. Down 1, right 1. We have that. This one is a solid line. All right. Let's just show dotted line. It is a solid line, but I'll go back. I'm going to get this wrong on purpose. Just to show you what you could see. And then we have our shading is 0 less than negative 2. Still no. So we shade below on this one. So we have to pick a point in this overlapped region. Everything looks great, except I already said this line needs to be solid. Alright, so I would pick 2, negative 6, say. Submit my answer. Your answer is not correct. Try and find the mistake. You got 1 attempt, so you're going to get 2 attempts total on this. I already told you that the second line I needed to change to a solid line. These are pretty simple mistakes that can be made going quickly. Solid, dotted, shading wrong, picking the wrong solution point by accident, little things like that. Take a minute and just check out what work you did already, and like I said, most of the time it's just going to be little mistakes with what we have there. So now I go ahead, reset that. I'm good to go after that. Alright, that's what we're going to be looking at. In our notes, I'm going to throw in a couple extra examples, but again, utilize the examples that they give you. And these ones aren't as good as the first ones. A little bit more in depth. I don't know how good my examples will be either, but I'll throw in a couple extra examples in our notes to hopefully help you out. But you have 13 questions. I don't think it should take long. I think the graphing's pretty easy. It's easier on the computer than with the phone, just with your fingers and trying to plot the points in the correct spot. It's just harder at times, that's all. But that's it. You got your survey this week. You got 1 Delta Math assignment, and that's it for the week. I've been happy with what I've been seeing out of you guys, and hopefully you guys are doing well, and if you guys need anything, let me know. I'll catch you guys later. Alright, see ya.